Good morning, students. Today we are going to discuss about the topic called as multiprocessor. So previously we discussed about single processor. So in that case, in a system we will be having one processor so that all the system related work and the user related works are done by the single processor. Okay. So then now we are coming for the multiprocessor. So what is the concept of multiprocessor? So that is, in a system, if we are having n number of processor, okay, then that system is called as what? Multiprocessor. Okay, so we can also call as multiprocessor operating system. So multiprocessor operating system. So what it is going to do here, what is the need, what is the use, or what is the concept, or what is the objective of having this multiprocessor? So basically it is used to improve the performance of the system. Okay, so the user applications or the jobs can be divided and executed by the n number of processor. Okay, so if the tasks are shared, means automatically the fastness of the system will get increased. Okay, so the jobs can be divided and executed more quickly. Okay, so once the job is completed, the results from all the processor are compiled to provide the final output. Okay, so what is the general definition for our processor means? So the multiprocessor operating system are used in the operating systems to boost. So this is the important word, to boost the performance of multiple CPUs within a single computer system. So it's a general definition of what is a multiprocessor. Okay, so here to improve the performance of the system, so more than one CPU are used within a computer system. Okay, so these multiple CPUs are interconnected, so the jobs can be divided among the processors to improve the execution speed. Okay, so in this case, so what is the exact definition about this multiprocessor means? So this multiprocessor is also called as parallel system, are also called as multi-core system. So multiprocessor is also called as parallel system, and also otherwise it is also called as a multi-core system. So here in this case, two or more processor, okay, two or more processor will be in close communication, okay, and by sharing the bus, that is a computer channel, and sometimes it also share the clock, memory, okay, memory and the peripheral devices. Bus, clock, memory and peripheral devices. Okay, so how we can employ this multiprocessing operating system means, so in this case with the help of our motherboard, okay, so with the help of our motherboard, okay, so the multiple processors are fixed so that it can be it is so that we can make a system with multiple processor. Okay, so what is a need, why we are going for this multiple processor? Okay, what is a need? The first one is to increase the increase the uh, performance, okay, increase the performance, and second is to increase the throughput. So what is this throughput? So that is with the less time cycle, the system needs to provide the or give the output. Okay, so with less time period, if the system able to give the output means, then it is called as what? Increased throughput. Okay, and then increased reliability. Okay, reliability. So what does it mean by reliability? If I'm having n number of processor, if one processor fails also, the remaining other process needs to complete the task. Okay, so in that case is called as what? Reliability. So in this reliability, we are having two concepts. One is graceful degradation. Okay, one is graceful degradation, okay, and another one is fault tolerant. Okay, so graceful degradation, supposing if I am having processor 1, processor 2, processor 3, okay, so the loads are given to each and every processor. Okay, so if this processor 2 fails, means the processor 1, processor 3 shares the load of this processor 2 and complete the task. Okay, so if the load is manageable by this processor 1 and processor 3 means, then it will share and it will complete the task. So that is the concept called as what? Graceful degradation. If the load of processor 2 is heavy, okay, and process 1 and process 3 is also executing in full time cycles, okay, so in that case the whatever workload allocated to process 2, so in that workload is shared to P1 and P3 but for a limited time period, and in this case the immediate recovery attention is needed to recover the problem of this processor 2. Okay, immediately the attention is needed to recover the problem of processor 2. Once it is recovered, what are the loads shared to this processor 1 and process 3, again it will take back and it will do its execution. Okay, so that is a concept called as what? Fault tolerance. Okay, so in the case of graceful degradation, the rest of the processor will manage to complete the task. Okay, but in the case of fault tolerance, whatever processor failed, the immediate attention is needed to recover the problem to continue the task without any further delay. Okay, so this is a concept called as what? Fault tolerance. Okay, so in the case of multiprocessing, we are having two types. Okay, in multiprocessing we are having two types. Okay, one is called as symmetrical multiprocessor system and another one is asymmetric multiprocessor system. Okay, so what is the case of symmetric and asymmetric? So first I'll tell you what is asymmetric. So in this processor 1, processor 2, processor 3 are there. Okay, so in this one, any one processor, supposing P1 processor will be considered as a master. Okay, and this master will allocate the process to rest of the processor. So in this case, this P2 and P3 is called as what? Slave. Okay, slave. So in the case of asymmetric multiprocessor, here it will follow a concept called as master slave relationship. So one process will take the whole in charge. Okay, so then it will allocate the applications to rest of the processors. Okay, so that is the concept of asymmetric multi-processor system. So here the processor cannot decide which process it's going to execute. Okay, but in the case of symmetric processor, okay, so if I'm having P1, P2, P3 means, so in this case each processor can take its own decision. Okay, so each processor can take own decisions, okay, to perform the perform the task. Okay, perform the task, and also it works in a cooperative way. Okay, cooperative way. So, right, so in this case, in the case of symmetric multiprocessor, the CPU scheduling is also simple. Okay, CPU scheduling is also simple. So these are the two differences between symmetric multiprocessor system and asymmetric multiprocessor system. Okay, so next one we are having the design issues, so that we will discuss in our next class.